Alright, well, welcome to the first part of a multi-part series to help you through the tic-tac-toe project, which is for Chapter 7, Project 7. Now, as you remember from your 150 class, you should always look at the logic of the problem and try to understand it, because if you don't understand the problem, how can you possibly solve it? And what that winds up doing, as you already know, is backs you into corners from which you cannot escape. Or multiple corners, actually. It's like, I like to use the analogy of a piece of carpet that's cut for a room, and it's cut a little too short on one side, so you start tacking it down on the other three sides, and when you finally get to the last wall and start pulling on it, you start stretching it, and then it pops up behind you on the other three corners. So you might fix it on that side, but now you've got three other corners that you've got to fix. Well, you can't fix it. See what I mean? So anyway, I've just done this in Word to try to expedite it a little bit. Here we have a 9x9 matrix, which represents your tic-tac-toe board. Now, in the traditional game, you're playing one human against another. Now, we're not going to get into any artificial intelligence, which is way out of the scope of this course. So the computer's not going to be looking at your moves and trying to deduce what to do to defeat you. However, we're going to have to do a little bit more than what the book is telling you, because the way they're describing it, let me get my book here. Let's see, it's page 470. The way they're kind of describing it is you just load up an array with zeros and X's and display them, and then there's going to be a winner. Well, hang on just a minute. If you do it that way, there can be two winners, depending on, I mean, if you're going to fill the board up, there's not always going to be just one winner, because these are randomly generated. You may have X's diagonally and O's horizontally. So how do you say X wins or O's wins when that happens? That's not going to work. Okay, well, think of it this way. When you play a game with someone, you play tic-tac-toe, and someone wins, which seldom happens, obviously, but let's just say that you're not really good at tic-tac-toe and the other person's obviously really good. And in 4 moves, they've got you. Well, that's the end of the game. Okay, at 4 moves, let's say X has 3 X's vertically in the first row or first column. Well, that's the end. That's the end of it. There's no more moves, because if you fill this thing up, you're going to wind up with 2 winners a lot of times, okay, which cannot happen. So essentially what you've got to do is you've got to decide whose turn it's going to be to start, which is going to be a random coin flip, right, using a random number. Now, there's a bunch of different ways to do this. I'll show you how I did it. And then you're going to, look at the array where you've randomly put these X's and O's, or whatever represents them, ones and zeros. And you're going to put a character in that label in that location. Then you're going to flip the turn and let then do it again for the O's, right? Here's the problem. What you're going to have to do is you're going to have to check for a winner every time you put an X or an O on the board. Now, you can optimize it and say, well, you got to have at least 3 moves before you can have a winner, so we're going to count, and if we have more than 3 moves, then we'll start checking. That's fine, but that's just, kind of bells and whistles kind of thing, tweaking it. We won't worry about that. So we're going to say here that every time you put a character on the board, doesn't matter if there's only 1 or if there's 9, you need to check to see if there's a winner, okay? So how are we going to do that? Well, let's look at the different ways that there can be winners, all right? And I don't naturally have this formatted the way I wanted it to be. All right, so then I have an X here, and an O here, and an O here. Well, an X here, and then an O, and then an O. Okay, there we go. All right, so we now have a winner. The game is over. But let's take a look. I'm going to go ahead and just fill this in with different things. All right. How many different ways can we win at this game, regardless of whose turn it is, whether it's X's or O's? All right. So what we're going to have to do is look at this in this matrix with rows and columns. You remember that from 150 class. It's an array, essentially, is a 2-dimensional array. We need to look. This is column 0. Column 1, column 2. This is row 0, row 1, and row 2. All right. So rows being horizontal, columns being vertical. We need to look at column O, column 1, and column 2 to see if we have X, 3 X's in a row or 3 O's in a row. If we don't, then we need to look at row 0, row 1, and row 2 to see if we have 3 X's or 3 O's in a row. If we still don't have a winner, there's two other ways that it can be accomplished. It can be accomplished diagonally, which is going to be hard for me to do this without a drawing tool, which would be essentially column 0, row 0, column 1, row 1, column 2, row 2. So you can have a diagonal win. You can have it going to the right, and you can have it going to the left. So if you check all 3 columns and all 3 rows and then the 2 diagonals and you don't have a winner, what does that tell you? It says you got a tie game, right? 9 times out of 10, though, you're going to find out that you do have a winner. Now I'm going to run this for you, hopefully, the one that I did. Now this is not the solution from the book. I don't do those. I just do my own stuff. So let's see what we got here. Function F5. Bear with me. I do have a new laptop, by the way. Now, obviously, they've shown you what they want as far as the form and the GUI and all that. So, I get 2 buttons. I got a label here with a 3D. I got a label here without a 3D, and I got 9 labels here, 3 by 3. That's it. Okay. So, new game. All right. You see what happened? I found a winner in the left diagonal, and I stopped as soon as I found that. So every time you put a character on the board, you got to check all of those axes, which are what? 1, 2, 3, 4, 5, 6, 7, 8. 3 horizontal, 3 vertical, and 2 diagonals. All right, and then I changed the color. I'm not doing any lines or anything fancy like that. It says O wins, X move first. So I'm recording who moved first and who won. So I'm going to click New Game. So O wins again, O moved first. X wins. Now, X won in 2 directions, but this is the first one we checked. All right? So it doesn't matter about that. I mean, you can get needlessly complicated on this. It doesn't really matter. X won again. O won. O won. Don't have a tie yet. O won. X won. Keep banging on it. Maybe I'll get a tie here in a minute. When I get a tie, I change the color to, gosh, there it is. Oop, I just missed it. There it was. There it is. Tie game. All right, I checked all the axes. I checked these 3 columns, these 3 rows, this diagonal to the right, and this diagonal to the left. I did not have 3 of any of my players in a row. So that means it's a tie game, and I just changed the color of that and put tie game in there. All right, so that's basically how that works. Now that you've digested that, I want you to think about it a little bit, and we'll pick this back up in part 2.